Okay, welcome. Friday morning, we are going to go over the homework from section 9.2 on finite state machines. I think this was pretty fun, so let's do it. Here was the assignment, page 538, 2, 4, blah, 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 blah. Okay, so number 2 was pretty silly. Oh, I should have drawn this table before the video started, sorry. Anyway, here it is. I'm almost considering skipping this problem because it's kind of mindless, but I did assign it, so you know. There are 3 states, S0, S1, S2, S3, and there are 4 possible inputs. Oh boy. So this is the table, and okay, I guess this is a good opportunity for us to talk about the fact that what is this table doing? It's describing the transition function, and the transition function is a function which takes an ordered pair and outputs what state you should go to. And it takes an ordered pair specifically composed of what state you're in and what your input is. And so the two-dimensionality of this grid is sort of, you're reading off the ordered pair inputs, and what we're writing in each spot is the output. It's just a binary function. So okay, I think that's pretty clear. Anyway, here is the information. I'm just rewriting what was in the book. S1, S0, S0, S3, S2, S1, S3, S1, and S0, S1, S3, S2. Okay, anyway, there it is, and the directions were, dude, just make the picture, the diagram for the finite automaton, which is captured by this. Okay, so this is, like I said, a little bit mindless. It's just testing to see if you can fluidly transition back and forth, or convert back and forth between all these things. This is kind of a complicated machine because we have 4 inputs, so I don't like that. But too bad. S1, S2, and S3. I don't think I even need my notes for this because, oh, and I guess S0 is the start state. So what do I now just need to draw? Just like a million arrows? Okay, so if I'm in S0 and I read an A, I'm supposed to go to S1. But if I read a B, I'm also supposed to go to S1. So I go to S1 on an A or a B input. From S0, and I go to S2 on a C input, and I go back to S0 on a D input. Okay, it's riveting. From S1, I should go back to S1 if I read a C or a D, but if I read a B, I should go back here if I read a B, and I should go to S2 if I read an A. So that's that. From S2, I should go to S3, if I read a C or a D, but I should go to S0 if I read a B, and I should go to S1 if I read an A. Sure, I guess I'm doing this right. Unlikely I made a mistake, but not impossible. Okay, from S3, I should go to S1 if I read a C, go to S2 if I read a D, and go back to S3 if I read an A or a B. I have no idea what this machine does. I do not care. I will never get that 10 minutes of my life back. Let's move on. Okay, sorry, once again I apologize for having to do this remotely. This is one of the most fun parts of the whole semester, and it's really nice when the seniors leave because there's all that senioritis negative energy, and suddenly they're gone, and there's juniors, you're getting robbed of this emotionally powerful feeling when suddenly like 25% of the school just instantly disappeared, and you get this strange sensation where you're like, oh, I'm a junior. No, I'm a senior. I'm still a junior, but like basically like I'm the oldest person in the school right now. Suddenly the class becomes like 12 people instead of 25 people, and you're like, whoa, I'm getting so much teacher attention, and everyone sort of moves together into the desk in the center of the room, and everyone is friends, and it's like you're getting some kind of posh private school education where the class sizes are really, really small and all your questions are getting answered, and it's very calm and quiet and it's peaceful, and we're all working together. And in fact, this day in particular, when we go over these, back when I had a real classroom with 2 full whiteboards that spanned the entire room, every single person in the class would just be standing up and we'd be drawing, and we'd go over this homework by everyone presenting a problem, and it was very happy. Instead, you're home alone in your house and watching this. While you're watching me do this. So that's sad. But nonetheless, we persevere. There's this machine, number 4, and I think this is actually just the hardest problem on this entire homework, and it's such a gossip to just kind of not really teach us how to actually do this problem, and just sort of let us suffer a little bit. So here's A, B, this is A, this is B, this is A, this is B, and this is AB. Oh, I should also say that it's like really easy to make mistakes, and so by sort of tradition, although you might say that this is the way I teach the entire class discrete math, but specifically with this unit, I don't worry too much about the details, and I just kind of do my thing, and I just count on everyone in the room to sort of correct me. So that's also sad for me, because since I'm alone, I'm supposed to be right and stuff, and no one is there, no smart people are there to double check me, which means I have to actually be correct, which is a lot of pressure. And hopefully I don't mess this up, and hopefully there's not some simple, elegant way that's superior that I'm not noticing. And if there are, then you can let me know later. Well, I stared at this problem for a really long time, trying to figure out what was going on, and because of the sort of looping nature and the sort of tightly connected graph of states, so to speak, it's quite difficult to figure out what this machine is doing. So, we can just talk it out a little bit. I start here in state W, an A could happen, then there's some sort of sequence of A's and B's could happen, and it might end up back at X, or it might end up back at Y, but eventually I get to Z. And so, okay, how should we think about this strategically? Well, I suppose we should start with the accept states. There's only one accept state, Z, and so any string that's going to be accepted needs to get to Z. And actually, once you're in Z, then the string will be accepted no matter what happens subsequently. So this little loop is just another way of saying, hey, regardless of what happens next, A or B, we simply just stay in this accept state. So once we get to the accept state, the string will get accepted. And so we really just need to figure out how to get to this accept state. So, alright, well, in order for a string to be accepted, it has to do something that lands me here. And okay, what are all the ways to land in this accept state Z? Well, one option is maybe just AA. That'll do it. So AA followed by anything at all is automatically a string which is accepted. Similarly, BB will be accepted. Okay. But also, like ABB will get accepted. Okay, but so will BAA get accepted. And then, okay, this kind of loop thing that's happening here suggests that there are some other possibilities as well that kind of generalize those 4 cases I just mentioned, which is that if I go to A and then do a bunch of B, A, B, A, B, A, B, A, and then do A, that will get accepted. Or if I go to B and then do A, B, A, B, A, B, and then to B, it will get accepted. And to generalize the third thing I mentioned, if we do A and then B, but then A, B, A, B, A, B, A, B, and then B, it will get accepted. And similarly, well, I'm wondering whether this is the right thing to do. I think it's okay. B, A, B, A, interesting. Well, okay. Anyway, let's just go and write this. Okay, what I think is interesting is that if you are following along in the textbook chronologically, like we would do in a normal year, or if you're following these modules in order, which is probably like the right thing to do, at this exact moment in our education, I have no idea how to write this, and it's actually interesting that we lack the flexible notation to describe all the things I just said out loud. And I don't know what, if you were a student, I don't know what you would write on your paper right now, exactly. And I think that's what makes this a really hard problem. But in fact, over the course of this unit, in fact, over the course of just this week, we learned some notation. The way Gossett presents it, we first study these finite state machines, then we study regular grammars, and in my 2-hour lecture I recorded yesterday on regular grammars, a big chunk of that lecture was me exploring some things that happened in section 9.3 of Gossett, which is a introduction to a bunch of bits of notation which help us describe strings. And those are really useful. You might say they're almost like essential to try to have any kind of serious conversation about machines like this. And then the last thing that happens almost last thing that happens this week is we learn regular expressions. And regular expressions are a very flexible and succinct notation for describing strings. And okay, you're probably already starting to get the idea that regular expressions, because they're called regular expressions, are somehow connected to regular languages and regular grammars and finite state machines. They all seem to be describing the same thing, and that's just true. Okay, so regular expressions are sort of uniquely suited to describing the outputs of a finite state machine. So let's skip ahead in time and let's just use regular expressions. And if you haven't watched the regular expression video at this moment that you are watching this video, then just like, whatever. Because I don't know how to do this otherwise. And let's begin. I'm not going to do this in full regular expressions, but I will utilize the concept of regular expressions to explain these 4 different options as I see it. I hope this is right. One option is there's an A, followed by some number of BAs. In other words, I start with an A, and then I do the BA substring some number of times. Okay, well that's what this star, this is called, okay, I'm going to mess this up, but it's spelled like this. I think it's pronounced Kleine, or Kleine. He's German, I believe, so Kleine, but it also could be Kleine, but also probably people say clean or cleany. Oh boy, I bet it's clean. The Kleine star says that what I'm trying to describe here is A, followed by 0 or more occurrences of the substring BA. So this is shorthand for A, BA, 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 some number of times. Possibly even 0 times, capturing the fact that AA is a way to get to that accept state. So we get A, BA, and then followed by A. And now I'm in Z, and so now what happens next is just irrelevant. And there's a way to write this, which is to say B or A any number of times. Okay, so, and this, once again, I use this star to indicate 0 or more times, because in fact, if we land, at the moment we land in Z, if the string ends, it should be accepted, of course. So some number of times, possibly 0, possibly as many as you want, you should have an A or a B. So, which is just a kind of another way of saying end the string however you like. Okay, this I think captures the path through the machine that effectively goes W to X and then some cycles with x and y, and then back to z again. Okay, but then there's the other option, which is that we go w to y, and then some cycles, and then to z. Okay, so that is going to be, analogously, b, a, b star, b, b or a. Okay, and now I have some doubt in my mind. When I did this 5 years ago, I did it one way. When I did it last night, I did it a different way. Maybe I'll do it even a different way now on the spot. But I need to capture the one where I sort of go w, x, and then but then end up at y, and then go to z. So I guess the way to think about that is that it starts with an a and ends with two b's. Yeah, I agree with my last night self. So if I do a, followed by some number of BAs, possibly 0, will keep me still at x. And if I then do one more B to get me back to y, followed by another B in a row, then I'm in state Z. And then at that point, anything can be done. Sorry, I might have been in the way of the camera. So yeah, I think the big picture way of thinking about that path is that it is effectively A, B, B, but with some looping that occurs, slowing that process down. Okay, and then the final one, analogously, would be B followed by some A, B loops, followed by two A's. Because and I'm in Y, but then AA is another legit path from Y to Z, followed by anything. Okay, so that was hard. And I'm only 99% sure that I'm right. And I've written this whole thing as a disjunction. And I don't have any way of checking to see whether I've done this correctly, except brute force case examination. And I don't know whether this is the same thing as some other thing that you might have done. So altogether now, the theory is kind of crying out for some more study of this phenomenon, of sort of converting a finite automaton into some sort of generic string which represents all the strings that are accepted by that finite automaton. And that's actually the first thing we're going to do next week, or perhaps it's one of the first. It's part of the first thing we're going to do next week is present an algorithm which converts this finite automaton to a regular expression. And I actually did that last night for this machine, and I got a single expression which represents this machine. But it is, though correct, it is very hard to understand, and so I'm not going to explain it this way. So this is an inefficient way of explaining what this machine does. But every string that in this language is of this form, this form, this form, or this form. All right, that was ridiculously long-winded, and that's becoming my trademark. So good. But I think like the rest of this whole homework is then not so hard. So all right, let's do it right now. Boom, 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 boom. 5A. Okay, what's 5A? It says write a machine that recognizes any string with an even number of ones. Ooh, I can do this. If it is to have an even number of ones, then I will start in the start state. And at this moment, do I have an even number of ones? I do. So I am happy, because I have an even number of ones. Which is another way of saying that the empty string, the null string, should be accepted by this machine, because it is a string of the language. The null string has an even, what is it again? Even number of ones. I'll just even write that. Even number of ones. And okay, we're assuming the alphabet is 0, 1, and all that kind of crap. Yeah. Okay, well, what if a 0 happens now? Well, then we are still happy because there are still an even number of ones. But if a 1 occurs, I should go to the sad place because now there have been an odd number of ones. And what will keep me sad is zeros, because a 0 doesn't change the fact that this is the state which really represents. Probably would be better pedagogically to label this not with a frowny face, but with something more semantic, like an odd number of ones have appeared so far. Of course, zeros don't change the status of that. But, of course, once a 1 happens, now I have, if I had read an odd number of ones, well, now I have read an even number of ones, and I can go back here. That's it. It's the whole machine. Woo! Good. 5C says, create a finite automaton that recognizes any input string that contains at least one 1 and at least one 0. Okay, so greater than or equal to, greater than or equal to 1, yeah, I'll just have to write at least 1, 1, and at least 1, 0. I think I have to write it like that. Woo! This is why people sometimes use A and B, because it's just more, it's a little bit more clear. You don't have to get these awkward moments like this. Okay. What should we do? Well, we should, in this case, we should start sad, because, yeah. So here's now my start state, and I'm sad, because in my start state, I have received no 1s and no 0s. But if I receive a 0, I should start getting a little bit happier, because now I have received a 0. Subsequent 0s don't make me any more happy than I already am. And there is an alternative route to happiness where I receive a 1. Because I am poised to accept strings which have at least one 1 and at least one 0. Well, here I'm sort of half happy or something like that. What will it take to make me totally happy? Will be if I get a 1 and a 0. And if I get a 1 and a 0, I should accept. And so from the I've already read a 0 state, I'm waiting for a 1. And from the I've already read a 1 state, I'm waiting for a 0. And once I have received a 1 and a 0, then I will definitely accept that string regardless of subsequent substrings, regardless of how the string ends. So that's it. Woo! Hopefully these are fairly intuitive. 6a, maybe I will move up here. 6a says, create a finite automaton that recognizes any string that contains the substring ABC. Okay, so we're looking for the substring ABC. Okay, we did something very much like this in the video, I think. So maybe this one's somehow even easier, I don't know, or just different. Well, now I will start sad, because in the start state I have not received any characters yet, so certainly the substring ABC has not come. What does it take to make me happy? Well, what it takes to make me happy is to receive an A. If an A comes, I'm starting to feel a little bit better. If a B comes, then I am feeling happy. And if a... Maybe this is just not a good system. Okay. Let's not do this. I love this kind of smiley face thing in a certain sense, but maybe I should really be training you to think more, to label your states with more sort of meaning and purpose. I think that's actually a better idea. So, okay, what is this? This is the state of I have just received an A. So let's label this state and think of it as the state I am in when the previous character was an A. Okay, and then if a B occurs, then I should go to the state of the previous two characters were A, B. And then, if a C comes, I should go to the state of the three previous characters were A, B, and C in that order. And that should be an accept state because I'm trying to recognize all strings with the substring ABC, and subsequent to reaching that state, all other characters are irrelevant because however the string ends, it doesn't matter. Once an ABC appears in it, then we accept that string. So this is sort of the path. And so I guess, what is this state? This is the state of the previous character was not an A. I'll think of it that way. Alright, and now all I need to do is explain what to do when I get frustrated and don't kind of get what I want. At the moment, this machine will accept a string if it begins with ABC. But the string might not begin with ABC. It might begin with a B, for example. If it begins with a B, then I just wait. And if it begins with a C, I also just wait. And so I should put a B and a C here. And stay in this, the previous character was not an A state. Okay, that's pretty clear, I think. What if I am here and I receive a C? Well, if I'm looking for the substring ABC and I made sort of 1/3 of the progress towards that, but now a C comes, well now that A is useless. And so I now have to go back to the state of my previous character was not an A. I guess it's actually more general than that. It's that my previous character yeah, because over here my previous character is also not an A. I don't know how to exactly refer to this state, so I'll just call it sad. Maybe that's better, actually, right? So if the string begins with a B or C, I'm sad. If the string goes A but then C, I'm sad again. But what if, this is the part that I think people find a little subtle, what if I'm here, the previous character was an A, but now an A occurs? Well, I wanted a B to occur, so I'm kind of sad, but I'm not all the way sad. Because if an A occurs, I can still just sort of stay here. After all, this is the state of the previous character was an A. So I don't need to go back to the beginning. After all, A, B, C would be great. So if I receive an A, and then another A comes, I don't restart, I sort of just stay here in a holding pattern, hoping the next character is a B. Okay, and yet now, make sure I'm not messing this up, yeah, I'm not. Now, what happens if the previous two characters were A, B in that order? Well, if there's a C, I go here, but if there's anything else, then this string is kind of destroyed, right? So if an A occurs now, I do need to go back to the beginning. Wait. No. Ooh, am I wrong on my paper? I think I am wrong on my paper. That's very exciting. Oh boy. Live thinking happening here. Be careful. I think if it goes A, B, and then B, I need to start over. But I guess if it's A, B, A, then I only go back here. That just seems right. Yeah? A, B, if an A, B occurs, then an A occurs, I shouldn't go all the way back to sad, I should go back to I just read an A. Yeah, so actually this problem's kind of hard, and is actually, I changed my mind, it's more complicated than the problem, man, I hope that's right. How could it not be? Well, I would love another human in the room to confirm this, but I'm 99% sure I'm doing this correctly, which means I did it wrong on my homework. And I think this is harder than the one I did in the video, so that's good. This was not a waste of your time doing this problem. Learning opportunity. Woo! 6C. Create a finite automaton that recognizes any string that contains at least one A, at least one B, but no C's. Okay, and I like how we've now converted to A, B's, and C's, because now I can say something like greater than or equal to 1A, greater than or equal to 1B, and greater than or equal to 1C, and now that's not confusing and weird. Okay, so we need some kind of A, B, and C. This one's also, I think, a little bit complicated. Let's go. Well, there's going to be a lot of kind of branching now, because I start here in this start state, and I'm waiting for an A. Oh, sorry, not great. Did I just misread the problem? 6C. Create a finite term of the records to any string that can use at least one A, at least one B, but no C's. Okay, at least one A, at least one B, and no C's. Alright, so immediately, if a C appears at any time in this string, then this string is to be rejected. And the way we do this is to create some kind of garbage fail state. So this is just fail. I should have a, well, I guess I'll just do sad. But it's worse than sad. It's just like sad with no chance of ever coming back from that sadness. So it's really like, it's like a dead, it's like dead. If a C occurs, that string is just dead, man. Good. And however, if an A occurs, so let this be the state represented by an A has happened, now there's still hope. In fact, this is getting good because I need an A and a B. And if a B occurs, well, that's also good because I need a B to occur somewhere in this string. And I think it's sort of clear now that there is this happy state in which I go when an A and a B and a C has occurred, but and all it takes to get there is another A. So BA should be one path through this machine if the entire string is just BA, but also AB should be a path through this machine. But things are a little bit more complicated. My happiness is not quite as stable and permanent as in some previous problems, because though any number of A's and B's is fine, if a C should ever come, I'm going to go from bliss to death. Really earning that health credit for this class, all it takes is one C to go from bliss to death. And that is also relevant here, that if a C should occur, I should go here. And in fact, you know, any C occurring at any point should send me from wherever I am to the state of this string needs to be rejected. This is what Gossi calls this a garbage state. And the key idea of a garbage state is you don't accept strings that end in the garbage state, but also it's sort of more extreme than that, which is that any subsequent characters read after arriving at a garbage state do not change the fact that you are still in that garbage state. It's actually, I think he calls it a black hole. You go into the black hole and you just stay there forever. And you can never leave, and you reject. So it's a way of just rejecting the string completely. Okay, do I have a couple? I think I have a couple more things to patch up. One is that if I read an A, reading more A's doesn't change anything, and here reading more B's doesn't change anything. And it's possible that now I am done. I just need to confirm that from each state I've accounted for everything, and I have, so we're good. Woo! Okay, well, that's actually a good transition point. We might very well have just stopped the homework there. That was a healthy amount of